Okay, maybe for the benefit of Hansha, who hasn't been with us for slightly more than 1 week, right? I've not seen you. Okay, I hope that you're watching the videos. Oh, okay, you have not named this video. Alright, so we have been looking at addition and subtraction of algebraic fractions, and in this chapter itself, we are concerned about having a common denominator before we can add or subtract any fractions. Okay? To achieve that common denominator, there are many ways to go about it, but the main important goal that we have is that it must be the lowest common multiple. Okay? Very often we have been checking whether our denominators can be factorized or not. If it can be factorized, then we should do that in order to effectively find the lowest common multiple of the denominator. Okay, so we will start by looking at exercise 6b, question 4, just warm up. Okay, this is in your textbook, page 143. Okay, we have this fraction here, 4f over 10f minus 5d plus 2d over 6f minus 3d. Okay, so as mentioned, we try to factorize the denominator if it's possible, and in this case it is possible because 10f minus 5d, it has a common factor of, what common factor does it have? 5, right? Okay, so we factorize our 5 and we have 2f minus d. Okay, numerator remains unchanged. And then in the second fraction, we can factorize out a factor of 3. So we arrive at this. Okay. And now that we have a denominator of 5 times 2f minus d and 3 times 2f minus d, okay, we can effectively find the lowest common multiple by deciding that between 5 and 3, the lowest common multiple will be 15. Okay? And then after that, 2f minus d is present in both, so we remain that, keep it unchanged. Okay, so this will be the lowest common multiple for both fractions. Okay? Then now we look at the left fraction. To get a 15, I need to multiply by 3, so on top, I will times 3 to the 4f. Right? And then for the right fraction, to get a 15, I need to multiply by 5 in the denominator, likewise in the numerator. So I'll have a plus 5 times 2d. Okay? Then we expand the numerator so that we can simplify it. So we have 12f plus 10d over 15 times 2f minus 10. Okay. You may need the answer at this stage, or you want to expand the denominator also can, or you want to factorize the numerator also can. In this case, if you factorize the numerator, you will be able to extract a factor of 2, such that we have 6f plus 5d. Okay. So we can see very clearly now, if we have factorized it, that there's no other common factor, no other way to simplify this question. Okay. common factor of 2. we need to do to achieve our denominator, a common denominator? What do we learn? This is not required today. Let's take a person and get ready to stand. Lucas A. You're supposed to sit there, and the rest. Okay, Satan, it's slower. Okay, Satan, can you tell me how to continue from here? 2m minus 5 over 3n minus 2 plus n plus 3 2 bracket 3n minus 2. Okay, alright, so what has Zayden done over here? Okay, thank you. So over here we observe that we have 3n minus 2 and 2 minus 3n here. Okay, they look the same but they're not equal. Okay, so we need to ensure that 2 minus 3n here is being flipped to achieve the 3n minus 2. Okay, but in order to flip this, we need to have an additional negative sign up here, and this additional negative sign, okay, will actually combine with this negative sign to become a plus. Okay, so what Zayden has done is that he skipped a few steps. In case you're not able to follow, I'll write it down here. So what he has done is that to do the flip, to achieve a 3n minus 2, he has a negative sign outside here. Numerator remains unchanged. And this negative with negative gives us a positive. Okay? So from here, at least now we see that we have 3n minus 2 appearing on both denominators. Then looking at 3 and 2, we can choose a lowest common multiple of 6. Okay, so now we handle the numerators. To achieve a 6, I need to times 2 times 2. So I will have 2 times 2n minus 5. On the right fraction, I will times 3 times 3 in order to get 3 times n plus 3. Okay, then we expand it and simplify it. So I will have 4n minus 10 plus 3n plus 9. Okay, and that leaves us with 7n minus 1 over 6 times 3n minus 2. Similarity between the denominators, meaning to say that there's a multiple of one to the other, or if I factorize, I'm able to see that there's a common factor. Okay, now we're going to look at questions such that the denominators do not have any common factor at all. Then what would we do? Okay, so looking at practice now 6 in your textbook, page 139. We are going to look at fractions that are like this. Let me write it all out first. factor, okay, between the two denominators here. So logically, what we should do then to achieve the denominator is that we take x plus 1 times 2x minus 5. Why is this a logical process? Okay, actually, if you look back at how we handle numbers, so let's say if I give you 2 over 3 minus 3 over 7, 3 and 7 has no common factor, okay, and we will decide that the denominator will be 21, right? And what exactly is 21? It is 3 times 7. Okay, so this is a case whereby there's no common factor between the two denominators, and that's how we did it in numbers. Okay, so therefore we do the same when it comes to algebra. Okay, in fact, the way numbers work, okay, all comes from the algebra concepts, right? Just that we do numbers first before doing algebra. Okay, so in order to get this, we then do the same idea, x plus 1 together x plus 1 times 2x minus 5. That means that over here, I need to multiply with 2x minus 5. Okay, so I need to multiply with this on both the numerator and the denominator. Okay, the things that I write in red over here is not necessary for you to write this working out. Okay, it's just for me to show you how I get equivalent fraction. Then over here, I will multiply by x plus 1 on both the numerator and denominator, which explains why here I will have 3 times x plus 1. Okay. Then the remaining process, expanding it and simplifying it. Do be very careful, this is a negative 3. Upon expansion, I should be getting negative 3 over here. That tends to be a mistake. So we have this, and further simplifying, I will have our x minus 13 or x plus 1 and 2x minus 1. But before I forget, use it in the point source. We share the time to change the duster from remember, it's getting challenging to erase. Please don't give your teachers extra homework. Okay. So let's look at part B, shall we? So in part B, although they look a little different, one is with y squared minus 9 and y minus 3. But we are aware that y squared minus 9 can be factorized. Right? How do we factorize y squared minus 9? How to factorize? Let's call another name. Simple for y today. Mission. And this thing we're still watching what's happening. Okay. 0. Can you tell me what is the factorization of y squared minus 9? Sure, y minus 9, y plus 9. Huh? 3 plus and minus? Oh, change the 9 to 3, okay. Yes. Okay, so y squared minus 9 is your y squared minus 3 squared. So we get y plus 3, y minus 3. Right? Okay. Then now that we have factorized it, what's our decision on the denominator? Okay, let's give some bullet points. What's the decision on the denominator? Let's choose Ethan. Asher looks a little bit slow, right? Okay, Asher, yes. Your denominator will be there's things in common, right, in the denominator. Y plus 3. Is it? That's all? 5. Okay, 10 is your 2 times 5, right? Okay, we have 5 on both sides, but in our denominator, we will choose 10. Alright, so just like in this case, we have y minus 3 on both sides. We will have y minus 3, but we also have the 1 plus 3 there. Okay, and so same logic. Right, so to have this denominator, our numerator for the left fraction remains unchanged, while for the right fraction, I will have y times y plus 3. Okay. Then I will continue to expand it. 2 minus y squared minus 3y over y plus 3, y minus 3. Okay. You can think the answer as such, but I just want us to challenge ourselves. What are the other equivalent forms of this expression? What are other equivalent ways? Let's give the action the points first. Action for your attempt, I give 5 points for you. Okay. Yes, please.
Factorize the y square minus 3y.
Factorize the numerator. Okay, so but in this case, it is a negative y square minus plus 2, sorry, and then minus 3y over here. So can you suggest that we can factorize the numerator? So if we were to do that, I'll do y and y first, ignoring the negative sign. 2 and 1 gives us 2. 2y here, and then y here. Both needs to be negative in order to get negative 3. Okay, while both negative multiplies to give us positive 2. But over here, I need a negative y square. Okay, so if one is positive, the other one negative, it will not work. So your factorization does not work. Because if down here negative, down here positive, multiply to give us this, but negative and negative give us positive. So this is not a factorizable expression in the numerator. Okay, so your numerator in this case cannot be factorized. Okay, yes, Hanshan. I'm just asking for other equivalent representations. Okay, giving an answer like that is perfectly fine. Alright, I want us to also acknowledge that it cannot be further factorized. Okay. Other ways of writing this answer, you can write it as negative y squared minus 3y plus 4. That's one other way. Okay, but making sure that all your negative signs and positive signs, they are all on top of the numerator, on top of the fraction line. Okay. If you put the negative sign outside of the fraction, what's the impact going to be like? Okay. It will be such that it will have to be a positive y squared, positive 3y, and negative 2. Okay. So these are all acceptable answers. They are all equivalent. They are all equal to each other. Follow? Okay. So why is it that down here must change to plus, down here change to minus? Because it's like you factorize our negative 1 for the entire expression already. That's why the negative sign is outside. Okay. Placed on the in the middle of the fraction. Questions? Okay, let's look at part C. Now we deal with 3 fractions. So in this case, when I have 3 fractions, what will we do first? Let's get someone to get the ball rolling. Rose. Why you diagonally? You were so sad, eh? Okay. Who was lower? One of the boys. Colin or else Joshua. Colin, your scissors paper stone. The user answer. Okay, yes, Colin. Okay, Colin, can you tell us what will you do first? Anything up to you. Sorry? Make the denominator the same, okay? What would the denominator then be? It's okay, just try. Okay, so Colin says that, okay, maybe before that, change the z squared minus 25 to z plus 5, z minus 5. Okay, let me just fill in all the blanks first, okay? So this is what Colin says. We agree with it? Thank you, have a seat. Okay, we agree? Right? Then after we have done this, okay, we can do the denominator, right? And what will the denominator be? Colin, you want to continue? Sorry. The denominator will be z plus 5, z minus 5. Great. Okay. So, we're now tackling three fractions together. The concept remains the same. Okay, it just means it's just slightly more tiring because there's three of them. So if I have my denominator to be this, let's look at it one by one. For the first one, you need to multiply with a z minus 5. So 1 times z minus 5. Followed by the minus sign that comes with the question. Then in the second fraction, I need to multiply with a z plus 5. So it is a 1 times z plus 5. Okay? I do not want us to skip the 1 because this is a minus sign. Remember when you expand it, this plus sign actually changes. Okay, so do be careful about that. Right? Don't skip the 1. Then after that, plus. This has no change since the denominator is unchanged. So we get 2z. Okay? Then now we can proceed with expanding the numerator. So we will have z minus 5 minus z minus 5 again plus 2z. Right? So I will have in the numerator 2z minus 10. Observation skills are okay, so you cannot just be thinking very strict steps itself. You must observe what is it that comes out of it. And okay, in the numerator, we see that there is a common factor of 2 such that we can get z minus 5, and this is a case whereby we observe that upon factorization, there is a common factor in the numerator and the denominator, so we can divide that away or cancel it. And then we will get an answer of 2 over z plus 5. Okay, so that will be the simplest form of answer. Questions? If not, I want you to give part D a try on your own. Likewise, I also want you to try out exercise 6B, question 4G, and 6D. Okay, could you please give these questions a try? Practice now 6D, exercise 6B, 2G, and 6D.
I didn't even see it.
Are they all correct? Any particular question that I will need to go through? Okay, so we see that all of them have done the factorization of the denominator. So given this, we factorize this. Okay, then after that, try to multiply with whatever that's missing onto the numerator, and then we get our answer. Okay. Likewise, for bracket also factorize the 4m squared minus 1, which is 2m minus 1, 2m plus 1, to get the common denominator, and then we simplify to get 8 minus 10m, in case you can't see at the back. 8 minus 10m times 2m minus 1, 2m plus 1. You may wish to simply factorize the numerator to 2 times 4 minus 5m over 2m minus 1, 2m plus 1. That's fine as well. Okay, but it doesn't help you in terms of simplifying. Okay. Then for Hash's answer, again, factorize the quadratic denominator, and then we arrive at this 2a plus 5 or a plus 3 times a plus 1. Okay. Any questions? Right? Before I move into chapter 6.4, I thought that let's come as a class, okay, to write some reminders for ourselves, lessons that we have learned regarding this topic itself. Okay? What will you want to remind yourself whenever you're dealing with this topic? The identities, okay? So apply. Which identity are you looking at? I think more commonly we see the a square minus b square being used, correct? So maybe instead of talking about identities only, okay, maybe we want to remind ourselves to try to factorize, okay, all denominators. Impossible, right? Because if we don't factorize, we will not be effective in finding our lowest common multiple for our denominator. So to factorize it, we commonly see cross method being done. Okay, likewise our identity a square minus b square. And then also earlier on we have seen just simple extraction of common factors. In the, I would say the worst case scenario, okay, it is to factorize by grouping. So we have learned these 4 different ways of factorization, okay, in our chapter 3 and 4. Okay, if you don't know what is the grouping one, it is the one where there's 4 terms, you need to do things in pairs. Okay, so these are the things that you want to remind yourself of. What other things will you want to remind yourself about? The denominator needs to be what kind? Must be lowest common multiple, right? Okay, lowest common multiple. LCM. Okay. Is there anything else that you want to remind yourself regarding this topic? After we have done so many questions, you can read through your own notes. Anything else that you think is worthy of a reminder? The flipping. Okay. So another thing that we have done is, okay, the flipping idea, right? So maybe I'll just write it as a minus b equals to negative e minus a. Right? If I want to flip. Yes, Kate?
But check whether the thing is to be factorized or not.
Check whether the eventual answer, okay? Yes. So if you recall just now, it's when we saw one of the question, if I had further factorized, I can still simplify the fraction. Okay? Check whether final answer be further factorized or further simplified by factorizing. Numerator and denominator. Okay, so these are all the skills that we have acquired in just this topic itself. Okay, so that's the thing about addition and subtraction. We need to be very careful and very mindful about what we're doing. Unlike our multiplication and division, whereby it's just numerator, numerator, denominator, denominator. Then we divide common factors to simplify. Okay? For addition and subtraction, there's a layer of difficulty. Right? Oh yeah, I forgot to keep points on. Okay. If we are okay, then I want us to take a look at chapter 6.4 now. Just do a few quick ones. Right here. 6.4 is an added layer on top of what we are doing in chapter 6.3. We're looking at solving equations instead. So earlier on is all expressions. Okay, now we're solving equations involving algebraic fractions. And this is not new to us because we have solved equations involving algebraic fractions before. Okay, perhaps to start off with looking at practice now 8 in your textbook, page 142. Let's start off with part B first. Okay? We have this equation 3 over 2b plus 3 minus 5 over 3b minus 4 equals 0. In case you can't see the minus sign, erase that little. We have done something like this before. Okay, not new at all. Because what we did in set 1, where we have fractions like that, okay, we said that since it's a 0 on the right side, I can bring this to the right side, right? And I can say that, you grab a better number, 3 over 2b plus 3 is equals to 5 over 3b minus 4. And if I have it in this form, what did we learn? We cross multiply, right? So the conditions for cross multiplication, when we said it in set 1, was that it must be a single fraction on the left, single fraction on the right. Okay, one fraction only. Okay, then we can cross multiply and equal sign in between. Okay, so cross multiply will mean that I will get 3 times 3b minus 4 equals to 5 times 2b plus 3. Right? Cross multiplication. Okay, and then we can get 3 times 3b, that's 9b, minus away 12 upon expansion, and here I will have 10b plus 15. Then, to simplify it, 9b minus 10b, all your b's on one side, all the unknowns on one side, and the numbers on the other side, so 15 plus 4. On the left, I'll get negative b. On the right, I'll have 27. But I'm trying to find b, not negative b. So b is negative 27. Okay. So that was what we learned. I find this a more efficient method. Is there another method? There is. Okay. I will just briefly mention this. I don't find that it is efficient in this particular question. Okay. Another method to be done for this will be that given this question, instead of moving the based on these two fractions, we just look for a single fraction first. Okay, so you can combine them into a single fraction. In this case, the denominator has nothing in common. I will combine them together to achieve this. I'm just going to demonstrate this to you. I want you to just get an idea that it's not very efficient, because to do this itself might be challenging for some of us. Okay, then after you expand the numerator. Okay, now you notice I never write the denominator. Why? Okay, because actually from this step, not only was I expanding the numerator, I also multiplied the denominator over. When I multiply it over, it is actually already a 0. 0 times anything is 0. Okay, so that's why my denominator disappeared. Okay, this only works for equation. It doesn't work for expression. So in your earlier on when you did your chapter 6.3, your denominator cannot disappear one. Okay, so then after that I will be able to solve 9b minus 10b is negative b, minus 12 minus 15, that will give us 27 on the right. So b is negative 27. Okay, I kind of reduced the steps a little. Okay, but in this entire process, there's a lot of attention that you need to give to each step in order to make it a shorter working. Okay, so I'll end here for this today. Tomorrow I'll continue by showing other examples, especially things like part A. Tomorrow our lesson is just 40 minutes. I hope that I can finish our chapter 6.4. Then for home-based learning, we shall be on chapter 6.5.